Today, I'll talk about BuildIt, which is a type-based multi-stage programming framework for code generation in C++. BuildIt is a library that lets you write programs in multiple stages, which means that the output of each stage is also some source code which can be further compiled and executed with new inputs. This can be repeated as many times as you want before generating the final output. Multi-stage programming is commonly seen in dynamic websites powered by PHP, machine learning libraries like TensorFlow, domain-specific languages and compilers, and metaprogramming languages like C++ templates, among others. Multi-stage programming allows the developer to generate specialized implementations that usually have a better performance without sacrificing generality, which allows the developer to support more applications with minimal effort. BuildIt uses a type-based approach, which means that the declared types of the variables and the expressions are used to decide what stage they would be evaluated in, as shown here. BuildIt also uses lightweight library approach, which means that you do not need a specialized compiler or an execution environment. You can use BuildIt just as any other C++ library with a standard compiler. The implication of this is that, unlike other approaches to multistaging that lack toolchain support or require a specialized compiler or use a completely different syntax for each stage, making it harder to move between stages, BuildIt uses a standard compiler, provides all toolchain support, and lets the developer move between two stages with minimum changes. We decided to implement BuildIt in C++ because many of the domain experts like physicists or chemists that we envision benefiting from BuildIt are already used to writing and optimizing C++. In fact, most of the domain-specific languages that we mentioned are all implemented in C++. Existing support for metaprogramming in C++, that is templates, is not the easiest to program and debug. C++ also lacks support for introspection and dynamic types, which makes this problem even more interesting. In fact, BuildIt is in our knowledge the first library in C++ that allows proper multi-stage execution without adding new syntax or without using a specialized compiler. BuildIt's programming model just adds the two new types, dynamic T and static T, which are used for declaring variables and expressions for two stages respectively. The details about how these types are used and how to add BuildIt program with these are covered in our paper and the full presentation. The full presentation also explains in detail how BuildIt uses repeated execution and bookkeeping combined with memoization optimizations to extract straight-line code, conditionals, and loops. We are currently using BuildIt to implement the graphic DSL with the G2 extensions. We do this by replacing the scheduling language with the first stage inputs and the algorithm language with the second stage inputs. We replace the compiler with a generic graph library written on top of BuildIt. Apart from this, we also added utility passes in BuildIt framework to automatically convert loop nests into CUDA kernels with user annotations, support for modular types that let the developer stack capabilities like Lego blocks for various analyses and pattern matching to specialize various nodes. With all these combined, we plan to support generating all the 576 variants that the G2 compiler is able to generate for GPUs with far fewer lines of code. Our paper talks also about various case studies where we have applied BuildIt to demonstrate benefits of its staging capabilities. BuildIt is available open source under the MIT license. On our website, we also have a live demo where you can write programs with BuildIt and execute them in multiple stages without having to download or install the library. Please reach out to us if you want to learn more about BuildIt or have any applications that are written in C++ and can benefit from BuildIt staging capabilities. Thank you.